grade 12 learners. Welcome to today's Life Sciences lesson. My name is Agnes Moabelo, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. I'm going to share with you WhatsApp number where you can WhatsApp your questions, your clarity-seeking questions. Remember, we don't need any voice messages or video calls. The WhatsApp number is 079-454-9535. I'm going to repeat the number. It's 079-454-9535. All right? So our first session for today is brought just in time to you by myself and by my co-presenter, Vedika Maharaj. So not forgetting that in this term 2, we have started with genetics and inheritance that carries 45 marks of our paper 2. Now the subtopic that we are going to be dealing with today is pedigree diagrams. Right. So in each lesson, you need to have the objectives to say what you want to achieve at the end of the lesson. What you want to achieve at the end of any content that you are studying. Now, I've got my objectives for today that I'm going to share with you to say at the end of this lesson, you need to be able to trace the inheritance of the characteristics over many generations. You can relate the genetic, the diagrams with what? With generations, link it to that. And you need to be able to interpret pedigree diagrams that can be given to you. And also we've got terminology that we have been learning at the beginning of the year as we were doing the DNA. Now we are doing genetics. Those terms are still coming. So you need to know the definitions of alleles. What are alleles? The genotype, difference between the genotype and the phenotype. You need to know the difference between the dominant and the recessive allele. You need to know the difference between the heterozygous and homozygous. Yes, you've been working on these terms since the beginning of the year. Also, at the end of this lesson, you need to be able to predict the probability of a child of a particular parent would inherit the trait in question. Okay, now looking at our pre-knowledge. Have you ever experienced in real life where maybe probably your parents were showing you some of your relatives to say, these are your relatives. You need to know them. These are your relatives. But you don't know how you are related, right? This also happens with me to say I've got many relatives, but some of them I don't even know how I'm related to them. Right, I'm going to share with you the 2 diagrams where you need to understand how you can connect your relationship with the other person or your immediate relatives. Right? So, the first one. Now, what is going to happen with pedigree diagrams? You can read them from top down or from bottom upwards. Okay? So, we've got... This is you, for an example, or it's me. I've got a brother, I've got 2 brothers and a sister. So myself and my brothers and sisters, we are called siblings. We are siblings, right? And then we've got our mom, we've got our dad, right? Now listen, our mom has got her mother and her father, her mother and her father. Then to us as siblings, they are our grandparents. So this will be your grandpa, this will be your grandma, right? Now when we read generations, our generations, it will be the first generation, this will be the second generation, this will be the third generation, meaning our grandparents are on the first generation. Our parents are on the second generation, and we are, as siblings, we are on the third generation. So generations can go on and on and on. Now listen to this one. Same as siblings, or you'll be having your dad. Remember, I related to your mother. Now is your dad. Your dad has got his mother and father, and they are our grandparents. Do you understand? So what is going to happen? You'll be having grandparents from your maternal side. You'll be having grandparents from your paternal side. I hope that makes sense. Now let me show you another family tree. Okay, this one I've started from bottom upwards. Let's start this one from top downwards so that you can relate to say when you'll be given those diagrams in your papers, you can start from anyhow, from top down or bottom up. Right, so this is a grandfather and grandmother. They've got children, and their children, they've got a daughter, they've got a son, right? Then a son marries. Then they have 3 children. Remember, the children are siblings. They sharing same parents, and they've got grandparents, right? Then on the other side, because we've said these grandparents, they gave birth to a daughter and a son. The son marries this woman, and the woman that marries this son, or the woman that is going to marry your uncle, is your aunt. Why are we saying this man is your uncle? Because it's your sister's brother. Then what does this mean? When they give birth to children, these are the 2 children, these children are going to be your cousins. Now your uncle's children are your cousins, right? So you and your cousins share same grandparents. Do you understand? So if you need to connect the way you are related, it will go on and on and on. Who knows? Maybe all of us, we are relatives today, right? So a pedigree is a map that depicts the different members of a family and their connections. It is a graph, and it makes assessing who is connected and their relationships, such as parent. I gave you an example of parents there, the siblings, as well as the cousins. Okay? Right, from our diagnostic report of 2020 and 2021, you need to be able to differentiate between phylogenetic tree and the pedigree diagram. Right? With the phylogenetic tree, what you need to know is that it's a diagrammatic representation. It is a diagrammatic representation that shows what? Possible changes in relationships, possible evolutionary relationships between different species. But comparing it with the pedigree diagram is a study of what? Inheritance of characteristics in a family over a number of generations. So this would make sense where if we say is a study of inheritance of characteristics in a family over a number of generations, you can inherit some of the characteristics from your grandparents and not from they are not visible in your parents, but they are only going to be visible. The characteristics inherited by you from your grandparents can be visible, whereas you cannot see some of the characteristics if we are to compare them to your parents, right? So a pedigree diagram shows the inheritance of genetic disorders. You can think of Down syndrome. So diagrammatic, showing the inheritance of genetic disorders over many generations. So in the previous slide, I've shown you 3 generations. Is you, your parents, and your grandparents. So as we are increasing in numbers when reproduction is taking place, it can happen that there are genetic disorders that can happen, right? And those can be transferred from generation to generation, right? Now for a second, can you be able to draw a family lineage showing 4 generations? Can you think of that? Can you be able to draw that? Right. I'm going to show you an example of a pedigree where it shows the lineage by indicating the 4 generations. Now, remember, in one of the objectives, you should be able to read and interpret the pedigree diagrams, right? Now, this is a family tree. Let's understand it according to what we have just learned. So, this means generation 1, this is generation 2, this is generation 3, this is generation 4. Let's check 1 and 2. If you are given a pedigree diagram in your exam papers, you are lucky because in most of the cases, they will give you the keys that will tell you what is happening there. Now with this one, we are given the keys. This square represents the male, the circle, the female, right? And they are not affected, right? For now, I'm going to use the word affected, not affected. But in your exam papers, they will be giving you maybe the type of the disorder there. So in there, you need to be specific, right? Now we've got a female. This represents female who is affected. So we've got a male, not affected, female, affected, right? Now from this generation to the next generation, they give birth to these children. How many children? So you literally need to count there. So this 1, 2 parent, they give birth to 1, 2, 3, 4, 5, 6 children, right? Now this, from these 6 children, if you can compare the first generation to the second generation, this daughter inherited the disorder from the mother. Can you see that? So it means characteristics were inherited from first generation to the second generation. Then the daughter, number 2, marries a male who is not affected. Now look at what is going to happen. They are going to have a daughter who is affected and a son who is not affected. Now, this affected female gets married to unaffected male. Look at this, what is happening. They are going to have how many children? Okay, these ones, they happen to be lucky to have 1, 2, 3, 4, 5, 6, 7 children. Out of those children, only 2 females were affected and only 1 male was affected. But then the 2 other females were not affected and the 2 other males were not affected. So if you can just check the trend here, is that the 4th generation inherited the disorder from the 3rd generation as well as from the 2nd and from the 1st. Meaning also that from the 1st generation, disorders or characteristics can be inherited from the 1st generation to the last generation. This is what we were saying when we were talking about the generations, right? On the other hand, remember they had child 1, 2, 3, 4, 5, 6. Child 7 got married to, is a son who is not affected, got married to a daughter who is not affected. Look at their son. Both of them are not affected, but they get a daughter that is affected. So it is possible that from the 1st generation, the characteristics can be masked and not be seen, but they are only going to be visible in the next generation. So this is true. This can happen. Now, this is a terminology that you need to learn, right? These are the terms under the genetics and inheritance. Also, we are talking about those when we look at the subtopic, pedigree diagrams. Right? Hereditary, what does it mean? Is the passing of characteristics from parents to offspring. We have observed that when we looked at our generations there. A gene is a segment of a DNA. Remember when we were even doing meiosis there, when we look at the chromosomes location of the gene, is a segment in a chromosome that contain the code for a particular characteristics, right? Now with the characteristic, it can be the eye color, for an example. My eye color can look the same as, or can be the same with my mother's eye color. Or my height, because I'm tall, I can inherit the tallness from my father's side. Okay, then we've got an allele. What is an allele? Is a different form of gene which occur at the same locus on homologous chromosomes. Remember with the terms, biological terms for your 1.2, you need to know all your terms for all your topics from DNA up to evolution. So it's important to know those definitions, right? Now the genotype. What is a genotype? It is a composition of what? Of organism. Remember with the genotype, you are not able to see that. You can't see that. But when you talk about the phenotype, with the phenotype, it's the physical appearance that you can see. It is the physical appearance of organism based on the genotype. For an example, you can tell that your friend next door there is short. Your teacher is tall. So the physical appearance you can see. So that's what we're talking about when we refer to phenotype. Right? Difference between dominant allele and recessive allele. Now with dominant allele, it is an allele that is expressed in the phenotype when found in the heterozygous condition. For an example here, I'm giving you the capital letter T and the small letter t. So this dominates. So they are not the same. The capital T and the small letter t, they are not the same. Hence we are saying they are in a heterozygous condition, and an allele that is expressed in the phenotype when found in the heterozygous condition and homozygous condition. We say they are homozygous because they are the same. Two capital letters, they are homozygous, right? Recessive allele is an allele that is masked in the phenotype when found in the heterozygous condition. It is only expressed in the homozygous condition. This is homozygous, right? It's in homozygous, but compared to this one, is in its heterozygous condition, right? Now, heterozygous, the difference between heterozygous and homozygous. Heterozygous is two different alleles for a particular characteristic. For an example, capital T and small letter t. They are two different alleles, right? And then homozygous is two identical. They look the same for a particular characteristic. It can be this one, two capital T's and also small letter t's. We say they are identical. They are homozygous. They are the same. They look the same. Right? Now, a pedigree diagram is used to study the inheritance of the characteristics in a family over generations. So these are the most commonly used keys, where we are saying the unshaded square represent the male that is not affected, whereas the shaded square represent the male that is affected. But then coming to the circle unshaded there, it is representing the female that is not affected, and the female, the circle that is shaded, represents the female that is affected. So sometimes you might not be given the keys, but you should be able to read those, even if not given, right? You need to remember steps when interpreting pedigree diagrams. There are steps that can guide you, that can help you. Step number 1. You need to study only the key and the opening statement. Remember, you are given a statement. This male, they will give you the characteristic, whether it's affected or not affected. Crosses with female, they will be explaining the characteristic there also. So it's important to explain, to write the phenotype of the male and the female given in that question. So you study the key that is given and the opening statements, then look for dominant and recessive characteristics and also the phenotypes. Step number 2, you write in the phenotypes of all individuals as given in the problem or in that question. Step number 3, you fill in the genotypes of all individuals with the recessive condition. By now, I hope girls and boys, you know the difference between recessive and dominant alleles, right? It must be recessive allele. That is, you fill in the genotype of all individuals with recessive condition. Now, with recessive condition, what does that mean? It must be the recessive allele. Now, how do you see that these alleles are recessive? They can be represented in lowercase. For an example, BB. Like when you talk about the height, it can be recessive, okay, TT, small letter TT. So the letters should be in lower cases and all of them should be homozygous. Right? Step 4. For every individual in the diagram that has recessive condition, it means that each allele was obtained from each parent. Remember the characteristics that you have. You obtain some of them from the father, some of them from the mother. If the parent showed dominant characteristic, remember, whenever we talk about the dominant characteristic, it's most appearing there. It is visible. It masks the recessive one. So if the parent showed dominant characteristic, fill in the second letter which represents the dominant allele, right? And then last step, any other individual showing the dominant characteristic will mostly likely be homozygous dominant or heterozygous dominant. We're talking about this, homozygous dominant or heterozygous dominant. Right? This is a genetic pedigree. This is the summary which is going to guide you on how to quickly interpret that. Like we have mentioned that, yes, keys will be given here. Now, the keys here, for an example, you are told that BR in this scenario, BR represent brown eyes, BL represent blue eyes. We also have got the genetic constitution of an individual. We given that this is homozygous, dominant, heterozygous, dominant, this is recessive, right? Then, if you look at the parents from first generation, right? We've got second generation, we've got third generation. So some of the characteristics are going to be inherited from the first generation. So those characteristics are going to, okay, in this case, the characteristics of brown eyes is going to be visible in the next generation. Let's look who is going to have brown eyes in this generation, right? You also ask yourself, in the next generation, who will be having the brown eyes in this generation? Remember, one generation gives rise to the next generation, so and so on and so on, right? So in this case, this is a male with brown eyes marries a female with blue eyes. What will happen to their offspring? Look at their offspring. This is offspring 1. This is the offspring 2. This is the offspring 3. This is the offspring 4. Okay? Now, obviously, Okay, let's look at the keynotes there. You study the key, that's what we have just said. Then look for dominant and recessive characteristic. Okay, now in this case, this child who showed heterozygous characteristics there, some of the characteristics were obtained from the mother, some from the father. Then happens to marry a female. This son marries a female who is affected, right? Who has the dominant characteristics of the brown eyes. So if you can examine and check all of this, you will realize that some of the characteristics were inherited from the parents. Even from their children, they inherit those characteristics from their parents. Now, you study the key, look for dominant and recessive characteristics, fill in the genotype of the individual with recessive condition, like we have done here. Each individual with the recessive condition will inherit one allele from each parent, whether mother or father. Then you can work backwards to fill in one recessive allele for each parent. Like we have said, with the pedigree diagram, you can work on it either ways. If the parent has a dominant characteristic, then what happens? You fill in the dominant letter, right? You fill in a capital letter as the second letter. And that shows a parent has got what? Dominant characteristics. Look at this one, dominant characteristics. Any other individual showing dominant characteristic is most likely homozygous dominant, and then homozygous dominant is represented in what? 2 capital letters. So with a genetic pedigree, it traces, most importantly, it traces the inheritance of characteristics over many generations. I'm giving you the hints there. With this one, you are being told that this female is non-hemophilic, this female is hemophilic, hence it's shaded, and this one is unshaded. And then we've got a male who is non-hemophilic, they are not shaded. And then male with hemophilic is shaded there. Then what is going to happen? Look at A, B, C. We have got A, B, C. Then what is happening there? The unaffected female is married to the affected. Oh, let me not talk about affected. By the way, it is given that is the female is non-hemophilic and the male is hemophilic. So we're saying a non-hemophilic female marries a hemophilic male. That's how you should put your concepts. Right? If a non-hemophilic female marries a hemophilic male, these are the chances of their children. 2 of their daughters inherited the characteristic of non-hemophilic from their mother. But look at what the son has got the characteristic. The son is hemophilic, meaning the characteristic was inherited, was transferred from the father to the child. So the son who is hemophilic marries a woman who is non-hemophilic. What about their children? They have 2 daughters who are non-hemophilic, and then they've got a son that is hemophilic. So what does this tell us? Is that because we are saying pedigree diagrams, they are responsible for what? You are there to see, you are there to trace, to track the inheritance of characteristics over generations. So this hemophilic disorder was visible in the first generation, but not from all the parents. But then look at what happens. Their children, one of them, which is the son, was hemophilic. And what is going to happen, or what happened? The son also had a son who is hemophilic. So it means hemophilic is a disorder that can affect mostly men. This is a proven diagram that showed us how some of disorders can be transferred. Now, you need to know the meaning of symbols and lines used in pedigree diagram. By the mere fact that you are given this diagram, yes, by now you know what does this represent. This is a male, female not affected, male that is affected. Yes, we'll be giving you the trait in the exams. Right, let's explain the lines. This line means marriage line. It means in the first generation, the mother who is not affected marries a male, or the husband who is not affected. Now this line going horizontal represents marriage. And then the one that goes down is the line of descent, to say these children were born of this from these parents in our first generation. Okay, so this line means descent, and this line between the siblings, or this line between the children, indicates that these are siblings. They are siblings. Okay, so this one on my far right, the 1 and the 2, this is first generation. This is second generation, right? So you need to be clear. So it's a given. So what I want to say to you now, with pedigree diagram, you really need to get your free marks there. As long as you can interpret those diagrams, that will help you. Let's look at this activity. Now it's important to read and understand all the questions in place. Let's read the question. Use the pedigree diagram to answer the question about dimples, and I'm explaining within the brackets that dimples are small depressions on the cheeks when smiling. You can check your friend next door if they've got those dimples. I've got 2. The dimple allele is capital letter D. It means it controls whether a person has dimples or does not have dimples. Okay, the allele for having dimples is dominant to the allele for not having dimples, right? Now, before you can even answer your questions there, you need to work on the diagram given. You need just to recalculate what you have there. How many females, how many males, how many are affected, so and so. Goes on and on. Right, key is given there. This is a male, not affected, then male affected, female not affected. Okay. In this scenario is the case of dimples, right? Having dimples and not dimples. So it's a male and female that have dimples. And then it is male and female, those that are shaded. It means they do not have dimples. So keys are given. They talk about the characteristics that are listed on the question. Right. How many family members have dimples? You go to the diagram and count. What is the genotype of the individual 3 and 4? State whether the following individuals are homozygous or heterozygous for living dimples. You look at number 2 and 9. State the family relationship between 12. Where is 12? This is 12 and 2. So you should be able to play around what is given. Right. How many family members have dimples? Now, we are given with dimples is unshaded. So you count. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simple, eh? is 10. You get your 3 marks there. What is a genotype of individuals? Now, the genotype of individuals, it is stated that the dimple allele is D, controls whether a person has dimples or not. The allele for having dimple is dominant to the allele for not having dimples. So, with the genotype of the individuals is small letter D and capital letter D and small letter d for both 3 and 4. 3 and 4. State whether the following individuals are homozygous or heterozygous for living dimples, right? Now, for number 2, remember, it's a female that has got what? Dimples. So it's homozygous there. And then what about 9? Where is 9? This is your 9, which is a male without dimples, with no dimples. So the male is going to be heterozygous. The number 9 is going to be heterozygous. Okay? And then state the family relationship between individual 12 and 2. Remember, those generations help us to connect the relationship between those individuals. Now, state the family relationship between 12 and 2. You go to 2. 2 is the female, right? And then 12 is the son in the 3rd generation. Okay? So it means 2 is the grandmother of 12. Right? Because the children for number 2 is 8, 7, 6, and 5. Then 8 marries 9. Then they have got this 1, 2, 3 children, a son, and 2 daughters. And only 1 daughter has or have dimples. Okay? So number 2 is the grandmother to number 12. Or individual 12 is the grandson of number 2. So you should be able to connect the relationship within the generations. How many offsprings do individual 1 and 2 have? Yes. How many individual offsprings do individual 1 and 2 have? So this is individual 1 and 2. And we are told from the passage that is given, right? We are going to read that question from those from paper 2 of November 2024. That is last year, still fresh. Okay, muscular dystrophy is a genetic disorder. Muscular dystrophy. You are lucky because you're given a term that you don't know, but then it is explained. So a muscular dystrophy is a genetic condition that causes what? Muscles to weaken over time. It is caused by a recessive allele on the X chromosome. So if this is a X chromosome, it will be having a small letter D there. This refers to what? It indicates that this chromosome is affected. The dominant allele XD, X with capital letter D, results in a normal muscle formation. Okay, the pedigree diagram below shows the inheritance of muscular dystrophy in a family. Now you go to the key again. It is given that this represents male without muscular dystrophy, and then the shaded one, male with muscular dystrophy, and this circle unshaded, female without muscular dystrophy, and the shaded one is female with muscular dystrophy. In fact, you are given the answers there. How many offspring do individual 1 and 2 have? Okay, remember this one shows descents. It means these children are born by these parents 1 and 2. 1 married 2. So how many children do they have? They have got child 1, 3, 4, 5. So how many are they? They are 3. All right? And then what is happening? In this second generation, remember, you can just write for yourself to say this is 1, this is 2, this is 3. It can also help you. Then what happens? Number 5, child 5 marries child 6. There are no more children, yes. Individual 5, who is a male without muscular dystrophy, marries a husband without muscular dystrophy. So these parents, they were without the dystrophy. They were without this genetic condition. Only one of their children, which is a male, inherited the disorder. Okay? Then one of their children marries a male without muscular dystrophy. Then look at the question. The pedigree diagram below shows the inheritance of muscular dystrophy. How many individuals, offspring? We said there are 3. Give the phenotype of individual 1. Phenotype of individual 1. Remember, it's given in the diagram that individual number 1 is a male without muscular dystrophy. So it's a male without, in fact, the answer is there. You just have to describe that phenotype. Genotype of individual 2. With the genotype that you cannot see, but with the phenotype we could tell that a male is without, according to the passage. Now the genotype of individual 2, remember this is a female, hence we having those, but then it is, we said this female, right, is without the muscular dystrophy, is without this genetic condition. Because it's a female, we said it's without, so this is this dominates this one. It masks this allele, right? And then explain why more males than females are likely to have muscular dystrophy. Explain why more males than females are likely to have muscular dystrophy, right? Look at this answer. Remember, think back of the chromosomes, because we know the chromosomes of the males is XY, of the female is XX or 2 X's. So what we're saying there, if we are to explain why more males than females are likely to have muscular dystrophy, just think of those chromosomes. XX has more chances, XY, right? Think of that. So males only have X chromosome. Can you see? They have got only 1 X chromosome and need only 1 recessive allele to have muscular dystrophy. That's 1 mark. Remember, it was for 4 marks. The X chrome allele on a male cannot be masked by a dominant allele. What about females? Females have 2 X chromosomes and need 2 recessive alleles to have muscular dystrophy. Can you see? So this only needs 1 because it has got only 1 X. But what about the female? Because they have got 2 X's, look at these alleles. So it's they have more chances of having the disorder, of having the muscular dystrophy. All right. So in females, a dominant allele on X chromosome would mask the effect of the recessive allele. Can you see that? So it depends on the question that is given. You need to describe the phenotype of each characteristic that is given. It's also important that when we're talking about the males there, the female cross between the male and the females who are affected, who are not affected, it's important that you describe the phenotype and also indicate that this is a male, this is a female, because you can even lose marks there if you don't describe, right? Let's do the last activity for this first session. Again, from paper 2 of November 2024. We are continuing with the last question there, number 4. Right. You had first generation, second generation, third generation, right? Parents not affected, but look at their grandchildren, right? Their grandchildren have muscular dystrophy. What does this mean to you? Parents 5 and 6. So this parent marries, is a female without muscular dystrophy, marries a male without muscular dystrophy, right? The question says, parents 5 and 6 plan to have another child. Use a genetic cross to show percentage chance of having a child with muscular dystrophy. Now, in this type of questions, when you'll be doing a cross, remember, we had parent 1 and 2. This is the first generation. It will be the first generation, F1, right? Now, the question says, use a genetic cross to show percentage chance of having a child with muscular dystrophy. Obviously, your question, because it's 5 and 6, these are P2. They are the parents 2, because these are the parents 1. They are the P1. So it will start with your P1 and F2. So in the immediately when you do a genetic cross, know that you're going to get those free marks. When I talk about the free marks, you need to indicate the P2 or P1, F2 or F1. So you get that 1 mark. All right. From this question, it says a female without muscular dystrophy marries a male without muscular dystrophy. Hence, we having this cross to show that the female is marrying or is getting married to a male. So female without muscular dystrophy marries, you put a cross, it's very, very important, a male without muscular dystrophy. We need to see this cross. Now the other, so what is going to happen? Then you write the genotypes of these males and females, right? So it's important to write correctly the phenotype of this male and female and also write the genotype, okay? Now, for meiosis to take place, we're going to have this separation of these gametes, right? For you to indicate that meiosis has taken place, you can just help yourself to say, oh, I'm seeing that this is meiosis, separation of gametes, then fertilization take place. You're also going to get a second mark free there. Where is the third mark? The third mark is going to be the compulsory question. Why are we saying, compulsory answer? Why are we saying this is a compulsory answer? It's because you are answering the question. The question says, show the percentage chance of a child having a chance of having a child with muscular dystrophy. It means your answer, your final answer where you show the percentage is a compulsory mark. So you need to have those 3 free marks. I'm saying they're free because it's simple to get. And if you don't answer the question, obviously you're going to work on the 5 marks because you did not show the final answer, right? Okay. Now, when fertilization has taken place, these are the genotypes of the F2 generation. From our second generation, you can see from the diagram that 7 and 8 are going to be they're affected with what? With muscular dystrophy, with this genetic disorder. All of them, because hence it's shaded. It means that individual has that genetic condition. Okay? So from 5 and 6, we are expecting those. Now, when you do your genetic cross, in your F2, you're going to have, okay, after doing all the crosses, right, make sure that this one crosses with this one, the first one, the second one, the first one, you cross it with the second one. Some of you prefer to use a Punnett square, but this is also working wonders because you can see what is happening. The second allele there, it crosses with the first, crosses with the second. Then these are the results. You're going to have 2 females. You're going to have 2 males. What about those 2 males? Remember, we must answer the question that show the percentage chance of a child having muscular dystrophy. So this child that is going to have muscular dystrophy is only 1, like you see here. So how do we calculate the percentage there? 1 out of 4 is 25% chance of a male without, of a male with muscular dystrophy. So there's 25% chance of muscular dystrophy child, as you can see with the genotype of the F2 generation. And that answers the question, because you are going to get all the 6 marks there. Make sure that you answer the question so that you get all the marks. These ones are given, don't forget. Okay? So I'm going to leave the second activity to be done by my co-presenter for our second session. And thank you so much. Make sure that you listen very carefully, and goodbye.
Welcome back, grade 12 learners, and thank you very much to my co-presenter Agnes for that lovely presentation on the pedigree diagrams. Just let's do a little recap before we carry on with the activities, because we had a bit of a break. So as Agnes explained to you very lovely, like this is something sort of like a family tree, okay? It shows us the different inheritance of traits and disorders in different families, okay? So it's inheritance of traits and disorders in a particular family, and that's why we say it's like a family tree. But I also want to remind you that what we are looking at here is one trait. When you're looking at pedigrees, we are looking at one trait, so we are still looking at monohybrid crosses, just the same as what the activity that she just showed you. Another thing that I want to remind you is that not all pedigree diagrams are going to be showing you characteristics or traits or disorders that are sex-linked. They can also be autosomal traits. Okay, so the pedigree diagram can represent autosomal traits or sex-linked traits. The question will always guide you as to which one they are actually asking you a question on. Right, so let's move on to the next activity. This activity is on Galt's syndrome. Okay, it's not always necessary for you to know what all of these different ones are. If the examiner wants you to know about a particular disorder, they will indicate to you some more information. The two that you need to know of the sex-linked inheritance, just to remind you of that, is color blindness and hemophilia. Okay, so I saw Agnes doing hemophilia earlier, and we are going to do one on color blindness just now. So those are the two that you are supposed to know it's sex-linked. Okay, so even though we already did sex-linked inheritance last week and the week before, it does not mean that it cannot be asked in a pedigree diagram. Okay, so you need to know those ones. Right, now let's look at Galt's syndrome. Oh, it so happens that Galt's syndrome is a sex-linked genetic disorder. So you see the question is clearly stating to you that it is sex-linked. And as soon as you see that something is sex-linked, you need to remember X's and Y's. Okay, so they go on further to tell you that it's caused by a dominant allele. Okay, and this is how we are writing the allele. And I also want to remind you that when it comes to sex-linked inheritance, the allele is carried on the X chromosome. The X chromosome is not the allele. Okay, the allele for that particular trait or disorder is carried on the X chromosome. So that is how we write it. Okay, so it's a dominant allele, that's why we have a capital G, and it's caused by the dominant allele. The diagram below shows the inheritance of Galt's syndrome in a family. Another thing that I want to mention to you, do you see that this particular disorder is caused by a dominant allele? It's not always caused by a dominant allele. Okay? The disorder is not always caused by a dominant allele. It is sometimes caused by a recessive allele. So we need to engage with this question and ask ourselves, okay, what do I need to remember about this? Everything I basically mentioned are the things that you need to think about when you are seeing the stem of the question. Okay, but let's take it a little bit further. Let's look at our options before we look at the pedigree diagram. What are my options of males that will be having Galt's syndrome? What would be their genotype? Okay, so first we have to write down the XY, because you know that is representing a male, and this is a sex-linked inheritance. And then you need to see that it's caused by a dominant allele. And how many X's does a male have? Only one. So if this male has Galt's syndrome, he will have a capital G. He will have the allele for Galt's syndrome on his X chromosome. Right. Now, what are the other options here? There are no other options. Okay, for a male to have Galt's syndrome, he will have to have that genotype. Now, for a female to have Galt's syndrome, there are two options. There are two options for a female. Why am I saying that? Because this option, which is homozygous dominant, that means that this female is going to have Galt's syndrome, right? However, if the female is going to be heterozygous, she will also have Galt's syndrome. Why am I saying that? Because the dominant allele over here is going to mask the recessive allele. In this instance, the recessive allele is normal and the and the dominant allele is the one that is causing the disorder. So if a male is going to be not have Galt syndrome, he would have to be, this would be the genotype, and a female to not have Galt syndrome, this would be the genotype. The female will have to have 2 recessive alleles in order to be to not have the characteristic, and a male would only need to have 1 recessive allele in order for him to not have the disorder. Okay. So when we're looking at, so this is a lot of information, right, that you need to think about. Now you go to the pedigree diagram and you ask yourself, what am I looking at here? I'm looking at Pitt and Gabby's family. Okay, it's Pitt and Gabby's family tree. They are the first, that's where we are starting. So therefore, Pitt and Gabby are our first generation. Okay, so this we have generation 1. Then their children are going to be the second generation, which is generation 2. And then their children's children are going to be their generation 3. So that's the first thing that we look at. We count the generations. Then we look at the key. Okay, I'm not going to go through all the steps that Agnes has done with you. You know that now already. But I want you to look at the key. It's very important that we look at the key because the key gives us the phenotype. And in life sciences, when you are writing your exams and when you are practicing, I want you to practice at looking at the question and stating the phenotype as it is said in the question. Now, we've said that for a couple of weeks now when we're talking about genetics, that when it comes to the phenotype, you look at the question. The stem of the question will give you the phenotype. And in a pedigree diagram, it's actually the key of the pedigree diagram, if it is there, that will give you the phenotype. So in this instance, they are using the words affected female and unaffected. They're using affected and unaffected. So then it is acceptable. However, if they are not using it, please avoid using the terms affected, unaffected, and normal, because they will tell you you would rather say male with Galt syndrome or female without Galt syndrome. Okay, but in this instance, you would be able to use it because it is stated in the key. Okay, a lot of finicky things I know, but it's important that we get it right from the beginning. Okay, so these are our questions. I'm sure you've already looked at them now that we have that we went through it. Okay, so let's go through them step by step. Firstly, we need to name the type of diagram shown. It is a pedigree diagram, not a phylogenetic tree. It is a pedigree diagram. Please note the spelling, very important. Number 2, how many females are in this family? Right, so now we go to all the females. So the females are depicted by circles. Okay, so how many females in total? Let's count them. This is number 1, number 2, number 3, number 4, 5, and 6. Yes, don't forget about these 2. Right? And then learners also tend to forget about this one. Poor Anju. Anju, just because she's married into the family doesn't mean she's not part of the family. Okay, so you would count all the circles in this whole family tree. That's how we get to 6. Then males in the F1 generation, how many have Galt syndrome in the F1 generation? Now, how do you count the generations? This one would be the P1, right? Then their offspring would be the F1. So that is the generation we are looking at here. And it is this one that is affected, so it will be 1, which is Pilusa. Then they want us to give Gabby's genotype. Okay, now this one is where we get a little bit tricky. So let's first have a look. What is Gabby's phenotype? Now we look at the key. It's a circle and it is shaded. If we look at the key at the bottom, it is affected female. So this female has Galt syndrome. Now remember we mentioned that Galt syndrome is with it's a dominant allele. Okay, so for her to have Galt syndrome, she definitely has to have one. One of them is definitely going to have to be this, right? But now the other X is going to have a recessive or a dominant allele. How do you work it out? Now you're going to ask me, but ma'am, it can be anything. No, what the clue is the offspring. We always have to look at the offspring. The offspring gives us the clue as to what the parents are. So let's look at the offspring. Pete and Gabby had 4 children, 2 males and 2 females. One of the males has Galt syndrome. One of the males does not. One of the females has Galt syndrome and the other female does not have Galt syndrome. Okay, so let's look at Pitt now as well. Pitt does not have Galt syndrome. Let's look at what Pitt, so Pitt's genotype is going to be like that. Okay, Pitt does not, Pitt does not have Galt syndrome. Sorry about that. It's a small g. Okay, he has the recessive allele, does not have Galt syndrome. Okay, Gabby, he does not have. Gabby does have Galt syndrome. Right, now we look at the children once again. What you know from sex-linked inheritance is that the father can only pass down the Y chromosome to their sons. So this one is going to have a Y chromosome and this one is going to have a Y chromosome from the father. But so which means their X chromosome has to come from the mother. So this one got an X chromosome for the mother, which is because this one is unaffected. So this one is going to have a small a recessive allele from the mother, and this one is going to have a dominant allele from the mother. Okay, because this one has, Pilusa has Galt syndrome, but the other square over here does not have Galt syndrome. Therefore, because the offspring has the recessive allele, they could, and it's a boy, they could only have got it from the mother. Are you with me? Okay, so therefore the mother's genotype will have to be heterozygous. Now, most of the time they love to ask us more questions. Sometimes they can ask you to explain your answer. Okay, but now they want to know something about Anju and Pilusa. Anju and Pilusa have 4 children. Give the phenotype of their sons. So here we have, they have 2 sons, okay? And we've got Anju and Pilusa. Now we go the same understanding as we did before. Now we look at what the parents are. We already spoke that Pilusa has Galt syndrome, so that is his genotype, and we know that Anju is normal, and not normal, does not have Galt syndrome. And because we know she doesn't have Galt syndrome, it means that she needs to have 2 recessive alleles, homozygous recessive, for her to not have Galt syndrome. So now we can easily work out what would be the children, but they want to know the phenotypes, ne? Okay, so what did we say once again? The Y can only come from the father, which means the X has to come from the mother. The mother only has the recessive allele, therefore both their sons will be unaffected, or more correctly, they will not have Galt syndrome. Okay? Now, what a lot of learners did was they wrote the genotype here, and that would be incorrect because the question asked for the phenotype. So don't get carried away. Like, I love genetics, so I get carried away with all the calculations and everything, and then I sometimes forget to answer the question. So always go back to the question and see what is the examiner asking me. Now we need to explain our answer. So the way, the understanding that I explained to you of how to get to your answer is basically what you need to write. Okay, you need to practice questions like this, grade 12, where you are having to explain what you worked out. Okay, so you start with the parents, because that's what you have. You have information about the parents. You want to have information about the children. They didn't even give you squares or circles or anything for the children to give you an indication. So you have to start with the father. So you start with what you know. Number 1, what is the genotype of the father, right? And what is the phenotype? So the Pilusa is affected, and you have the genotype there. Anju is unaffected, and you state her genotype. So you state the father's genotype, you state the mother's genotype. Then you look at where the inheritance will go. Exactly what I said. Males are going to inherit the Y chromosome from Pilusa, who's their father, and they're going to inherit the recessive allele from Anju, which is their mother. That's all you need to say. 4 marks in the bag. Right, so now we have another question over here that has got to do with deafness, okay? One type of deafness in humans is carried on a single allele. The diagram below shows the inheritance of deafness in a family. Right. Now, why I'm pausing here is because once again, all of that information that I told you, we need to do again. Number 1, they talk to you about deafness. So that is the trait that we are looking at. It tells you it's carried on a single allele. Does it tell you that it's sex-linked? Is there any indication here to you that it's sex-linked? Have they given you the alleles? No, they have not. So we must already know that this is an autosomal trait. Write it down for yourself, that it's an autosomal trait. Okay? So we are not having X's and Y's grade 12. Just because there are males and females in here, it doesn't mean that it is males and females. Okay. The other thing I wanted to mention quickly, I'm not sure if Agnes did mention it, but it's very important as well, that when you are doing pedigree diagrams and you are doing genetic crosses, because she did one with you, the previous activity, right? That the last activity Agnes did. It's very important that in the phenotype you mention male. You have to say male with Gold syndrome, female without Gold syndrome, or male that is deaf, or female that is not deaf. Okay, it's very important that we always mention that, especially when it comes to the sex-linked inheritance. Okay, so just get in the habit of doing it always, right? So in this instance, how many generations are represented? So, sorry, one more thing. They don't tell you here, because they don't give you the allele, you also don't know which one is dominant and which one is recessive. Is hearing dominant, or is being able to hear dominant? We don't know. Okay, but the information in this pedigree diagram is going to guide you. Okay, but let's first answer the questions one by one. How many generations are represented in this pedigree diagram? So like I explained to you, this is Paul and Lizzie, and Mary and John. These are two families, okay? We have two parent groups here. That's the first generation, the second, and the third. Right? Children of Paul and Lizzie are able to hear. So let's see, here's Paul and here's Lily. You can see there that they had 3 children. 2 are able to hear and 1 cannot hear. How do I know this? Because we look at the key. The hearing is unshaded and deaf is shaded. So how many are able to hear? It would be 2. Right? Because it's this one and this one. Which phenotype is dominant? So here they're asking us now, which phenotype is dominant? Now you're going to ask me, ma'am, how am I supposed to know this? Remember, I always said the children are the key. The children are the information that is given, that it will be able to explain to you which one it is. And the best way for us to look at this is if we look at parents that are hearing. Because think about it. If they have 2 parents that are able to hear, and they have a child who is deaf, where did that child get that allele from? It had to have come from the parents, right? So the mother or the father has to have the allele. So let's go a step further. Let's look at who are the 2 parents here that we can see that are hearing. It's Bob and Ann. Let's look at Bob and Ann. Okay? You can see over here that Bob and Ann are both hearing, but they have a son who is deaf. Now, what would the son would have to get 1 allele from the father and 1 allele from the mother. Okay, so this can only mean that in order for him to have it, he would have to have 2 recessive alleles. Okay, and getting 1 from the father and 1 from the mother. We are not talking about X's and Y's here. Now we're not talking about inheriting the Y and all of that. Okay, we are talking about just straight alleles. So he must have inherited 1 from the mother, 1 from the father. The deafness allele would have to come from both the parents. 1 from the father, 1 from the mother, but the mother and the father are not deaf, which means that the mother and the father have to be heterozygous. Are you with me? So you just explain it like that. You explain to us what the parents are, you explain to us what the child is and the possible genotypes, and that's how you get to your answer. So which phenotype? So that will obviously mean that hearing is dominant because both parents are heterozygous. So the dominant allele is the one that is in the phenotype, and that is going to be hearing. So the dominant allele is hearing. Use the offspring of Bob and Ann to explain your answer to question 2. Okay, so that is exactly what we are going to do now. We are going to say Bob and Ann can both hear. but they have a child who is deaf, and or you can say the genotype is homozygous recessive. This means that each parent carries an allele for deafness. That's exactly what I said, right? Each parent has to be a heterozygous, or each parent has to have this recessive allele. Otherwise, how would the child have it? But this recessive allele that the parents have is masked by the dominant allele, which is for hearing. Okay, so this is how you answer a question like this. You talk about what the phenotype of the parent is. Then you talk about what the genotype or the phenotype of the child is, and then you talk about how they've inherited the alleles. Okay. Number 4, use the letter A to represent the dominant allele and the letter small a for the recessive allele to give all the possible genotypes for a hearing individual. So now that we know that the dominant allele is hearing, for a person to be hearing, what would they have to have? Yes, A or A. Yes, homozygous dominant or heterozygous for hearing, because the allele for hearing is going to mark the recessive allele for deafness. Okay, so that is how you get to that answer. Now, this is a homework activity, but I just want you to show something. This particular one is on color blindness. I want to mention a few things to you here on this one, and we still have a bit of time. Okay, so we can actually do, for more practice, I think it's good for us to do this activity. Okay, this is a pedigree diagram showing the inheritance of color blindness. It's also known as daltonism in a family. Color blindness is sex linked and is caused by a recessive allele. Okay, they're showing you it's like that. The ability to see color normally is caused by the dominant allele. But can you see here that they did not tell you about the X's and Y's? But what do you know about color blindness? It is sex-linked inheritance. So because it's part of the examination guideline, and you're supposed to know that color blindness is sex-linked inheritance, they don't have to indicate to you about the X's and Y's. A little bit of a trick here, okay? So how many of the female offspring of parents 1 and 2 were normal or have normal vision? Okay, so here's 1 and 2. How many have normal vision? Of the male offspring, it's 1, 2. 1 and 2. We don't count this one because this one is married in the family. Okay? What percentage of males in this pedigree diagram are affected? How do you work it out? You count how many are affected, and you see there's 1 male that's affected, and out of how many total males are there? There are 1, 2, 3, 4, 5, 6, 7 males. So you'll say 1 divided by 7 times it by 100, and that's how you get your percentage. State the genotype of individual 2. So we go to individual 2. What is individual 2? It's normal vision female. So what would be the genotype for a normal vision female? Okay, it would be normal vision. However, they have a child that is colorblind, therefore they must have the colorblind gene. You see that? They have a child who is colorblind, so he must have gotten the allele from the mother, because the father does not have, and the father is going to pass the Y chromosome to the son. And individual 5, so we look at individual 5, that is a colorblind female, so they will have to be having 2 recessive alleles. Then they have a last question: if individual 5 marries a normal male, so if it marries a normal male, right, then what percentage of their daughters will have an allele for color blindness but will not be colorblind? So how many of them will basically be heterozygous? So we can quickly do a small little Punnett square to work that out. Let's quickly do that. It's only 1 mark, right? So you can quickly just do your small little Punnett square. You put in your gametes. I should not be writing here, sorry. Let me do it this side. Right, D. And then we have here capital DY. Okay, so they want to know about the female. So let's do it that one. There we go. Right, you can already see it coming together over here. Okay, so then those are the females. So how many females would it be? It will be all of their females. It says what percentage of their daughters, not what percentage of their children. If they had asked, and why am I saying 50%? Because it's 2, right? If they had asked what percentage of their children would be normal or would have normal vision, then it would be 50%. But they asked how many of percentage of daughters. They only, in this instance, it's 2 daughters, so it will be all the daughters basically. Okay, so in any time they would have daughters, this is how it would work out. Okay, then let's finally wrap it up to things that you need to remember. Okay, so oh yeah, and then before we go to things you need to remember, every lesson has a worksheet. Please make sure that you get the worksheet from your teacher. And that worksheet, it's basically the questions. Sometimes it's questions that we've already done, and sometimes there are questions that we have not done, but there are questions so that you can actually work it out. So you have 2 options. If you're watching this lesson live, which we really hope that you are, then you can have the worksheet in front of you and you can work it out and go through the questions when we are doing them. Alternatively, you can always get it afterwards and you can always watch the recording. It's still available on Pocket School, and there you'll be able to see do the worksheet while you are listening to us so that you are actually learning. There is no point just sitting and watching us teach when you need to actually engage with what we are saying in order for you to learn. Right, so things to remember of pedigree diagrams. The difference between pedigree diagrams and phylogenetic trees. Here, spelling is very important. Knowing how to spell pedigree and phylogenetic trees. Because phylogenetic trees, you're going to use that term when you do evolution. And if you spell it incorrectly, you're going to get it wrong. And let's remind ourselves, what is the difference? The pedigree is like a family tree. It's showing the inheritance of disorders and traits in a family, whereas a phylogenetic tree is showing your species, different species, right? And the traits. All pedigree diagrams are not representing sex-linked traits. Very important, grade 12s. When you see a pedigree, it does not mean that it is always sex-linked. So it doesn't mean that you're always going to use X and Y. The question will tell you when it is sex-linked by either indicating it with the term or by the allele represented. So example, if they give you the allele like this, then you know that it is sex-linked. Okay, so this one is sex-linked. With regards to the phenotype of the individuals, always write the phenotype as stated in the question or the key. In the question or the key, state the phenotype as given. Avoid using terms such as normal, unaffected, or affected to describe the phenotype unless it's stated that way in the question or the key. Always add male or female in the phenotype. Okay, so like I said, when you have the phenotype, you're going to say male with color blindness, male without color blindness, or male with normal vision. In that instance, normal vision I think would be accepted because that is what we would have for normal vision. However, to be absolutely safe, you can say a female with that is not colorblind. Okay, a male with hemophilia, a female without hemophilia. Okay, or non-hemophiliac. Right, but rather just be safe and be guided by the question always. Right, and then we have the next lesson. Okay, so that brings us to the end of the pedigree diagrams. Grade 12, the pedigree diagrams, how to answer questions on this is a skill. And skills must be practiced. Okay, so please do as many questions as you can. Try to practice autosomal traits and sex-linked traits so that you can be exposed to all of them. What I want you to notice is that Agnes and I did 4 with you, and some of the questions were repeated. Okay, so that's what I'm saying. Even though all 4 of them were actually addressing different traits and they were all slightly different, they did have similar questions. Okay, so it doesn't mean that the question is going to be repeated and that it is repeated. It just means that it is a skill. We can ask you the same question to an entirely different context, but you're going to use the same skill to answer it. Okay, so please go ahead and practice all your genetic crosses, and you'll see us next week, Thursday. Please take note that our lessons are now at starting at 2:30 to 4 o'clock, to make sure to pester your teacher so that you can log in, and we are going to be doing mutations and genetic engineering. See you then. Thank you.